Hello everyone, and myself Nirmala. Today I am going to explain my project thesis. And the first part is abstract. Safety in industrial site environment is paramount importance to protect the well-being of workers and prevent accidents. Safety helmets are essential personal protective equipment that help reduce the decrease the chance of a head injury, hazardous work settings. To enhance the safety compliances and monitor helmet usage, we recommend a safety helmet detection using Opencv computer vision library. The primary goal of this project is developing an efficient and reliable solution for automatically detecting whether individuals in an industrial individuals wearing headsets, and the system employs a state-of-art object detection technique to ascertain and localize the safety helmet in real world images and the R video streams. The project begins by curating a data set containing annotated images of workers with and without safety helmets. We leverage the power of Opencv, a popular open source computer vision library, to implement the object detection models. Specifically, we explore the you look only once algorithm, known for its real-time performance and accuracy. The implemented system demonstrates robustness in various industrial scenarios, including challenging lighting conditions, occlusions, and partial helmet obstructions. We evaluate the model's performance against the set of benchmarks, achieving a high accuracy rate in safety helmet detection. Moreover, the safety helmet detection system is designed with the scalability and adaptability in mind. With these, it can be integrated existing surveillance infrastructure on deploy on edge devices for real-time monitoring in industrial setting. The solution can be extended in corporate multi-class detection for identifying other safety gear, further enhancing the safety compliance monitoring process. Through the project, we represent a valuable contribution to industrial safety by automating the monitoring of safety helmet usage. By leveraging Opencv and the object detection technique, our system offers a cost-effective and efficient solution to reduce the possible head damage and improve overall safety compliance in industrial environment. And the keywords we used are safety helmet detection, Opencv, object detection, industrial safety, computer vision, and personal protective equipment compliances. And then the introduction. Safety is a paramount concern in industrial environment where workers often face potential hazards and risk. Personal protective equipment plays a crucial role in safeguarding workers. The safety helmets are essential component to protect against head injuries in industrial settings. Requiring workers to wear helmets at all times is crucial to prevent accidents and maintain a safe working environment. To address this important safety concern, we propose a safety helmet detection in industrial site using Opencv project. The primary aim of this project is developing an industry's intelligent and automated mechanism that is precise detect whether individuals in an industry wearing helmets or not. By leveraging the computing vision techniques and the Opencv library, we can efficiently monitor and enforce a safety compliance in real time. The project's core methodology involves utilizing advanced object detection algorithm with a focus on YOLO, a state of the art of deep learning based model re-owned for its real-time processing capability and high accuracy. Through integration using this model into Opencv framework, we can analyze images and streaming of footage from a security camera placed strategically through the industrial site. To make a robust and effective system, a comprehensive data set is curated, comprising annotated images to instruct the think detection model, enabling it to recognize and localize safety helmet accurately. The safety helmet detection system is designed to handle various real-world challenges such as varying lighting conditions, occlusions caused by the machinery and the other objects, the partial helmet obstructions. By addressing these complexities, the system is able to deliver accurate results in diverse industrial scenarios. Furthermore, the project emphasizes scalability and adaptability. The solution can be integrated with existing surveillance infrastructure or deployed on edge devices for a real-time monitoring, ensuring quick feedback and timely response to safety non-compliance. Then the second part is literature survey. Long X and Jeng conducted a research on safety helmet wearing detection, which is crucial for ensuring the safety of pre-ambulatory workers in various environments, particularly in power plant. Previous methods focused on handcrafted characteristics like color and shape for helmet detection. However, with the rising popularity of deep learning, they proposed a more effective approach using a deep convolutional neural network DCNN called the single shot multi-box detector SST. The research introduced a novel practical safety helmet detection system based on SST, as the safety helmets are often small objects that can be challenging to detect. They tested their approach at a power substation and demonstrated its efficiency and effectiveness. The main challenge in the power station monitoring is identifying the safety helmet wear. Early methods relied on a manual selection of features based on the color and shape. However, the research used deep learning techniques, specifically SSD, for precise and accurate safety helmet detection. They also develop a dataset specific to power plant scenario for training their model. The outcome of the experiment on the dataset significantly outperformed the original SSD detector, especially for detecting safety element. Additionally, their system achieved a real-time processing speed, operating at a 21 frames per second. These advantages make their safety helmet detection system highly suitable for power station surveillance applications. In summary, the researchers proposed an efficient and effective safety helmet detection system using deep learning and SSD, which outperformed traditional methods. It has important ramifications that their work for enhancing safety measures in power plants and similar setting where safety helmets compliance is critical. The second author is Divala and Grishchik and Randon introduced a novel method of object detection called YOLO. You only look once. Unlike earlier strategies that relied classifiers for the object detection, YOLO conceptualized the object detection as a regression problem. It determined immediately bounding probability for classes and boxes for the things all in one neural network assessment, making the detection pipeline more efficient and tunable. YOLO's integrated architecture is remarkably fast, processing images in a real time at a frame rate of 45 frames per second. Even a scaled down version, fast YOLO 155 frames per second, while still maintaining a high frame rates outcoming different instantaneous detectors in terms of MAP, mean average precision, by a factor of 2. Although YOLO generates fewer false positive prediction on background, it may take more localization error. However, it excels at capturing broad representation of objectives, making it perform better in domains beyond the new natural images, such as artwork, when compared to the other detection techniques like DPM, deformal part-based model, and RCNN, region-based convolutional neural network. The YOLO model is easy to build and it is trainable quickly on entire images. It uses a loss function directly related to a detection performance, making it more effective than classifier-based approaches. Fast YOLO stands out as the fastest general-purpose object detector, enabling instantaneous object detection in various applications. Additionally, YOLO demonstrates effective generalization to new domains. This makes it the perfect option for application needing quick and reliable object detection. In summary, YOLO is an innovative object detection algorithm that offers a fast and precise detection among images. Its capabilities have a significant potential in enabling a responsive robotic system, assisting devices that precise the real-time scene information, and enabling autonomous driving without specialized sensors. The author Goyal and Grishchik compare a two-stage object detection algorithm like RCNN renowned for their extreme precision but computational complexity with one-stage detector that offer potential speed and simplicity benefits. They investigate the reasons behind the performance gap between the two approaches when densely sampling object locations. Their research identifies severe foreground background class imbalance as a main obstacle faced by the dense detect. They recommend a plan to deal with this problem solution called focal loss, which modifies the convolutional cross entropy loss of a d-value example with a clear classification. This approach helps correct the class imbalance and prevent the detector from being overwhelmed with the easy negative example during training. Instead, the training focuses on a smaller set of a challenging example. They develop a straightforward dense detector called RetinaNet to assess the effectiveness of their proposed focal loss method. The findings demonstrate that RetinaNet achieves a comparable speed to earlier one-stage detector while outperforming all current state of the art of two-stage detectors according to accuracy when instructed with the focal loss. In summary, their work aims to bridge the performance gap between two-stage and a one-stage object detection algorithm. By introducing the focal loss method, they successfully addresses the class imbalance issue and create a highly effectively fully convolutional one-stage detector RetinaNet. The experiments conducted on the challenging COCO dataset validate its a state of the art of both quality and effectiveness, speed and the accuracy. Bergley and Irhan Reed and Fu present a novel method of detect objecting called SSD, single shot multi-box detector, that utilizes a single deep neural network, that is SDD. And SSD discretizes the limiting box output space into difficult boxes with a different aspect ratios, the scale for each position in the feature map. The network predicts every item's presence type in each pre-filled packages and adjusts as a box to fit its object space better. To manage numerous item sizes, SSD utilizes the forecast from several feature maps with various resolution. The key advantages of the SSD is eliminate the need for proposal generation and subsequent resampling phases, making it simpler to train an intelligent to detection system. Experimentation with the popular datasets like Pascal, Oak, and COCO and ILSVRC demonstrate that SSD achieved a competitive accuracy compared to methods with a proposal phrases, but it's significantly faster. It provides a common foundation for modeling, training, and usage. The researcher emphasizes the importance of using outputs from multi-scale convolutional areas, delimiting various attribute mapping to simulate the range of potential box shapes effectively. And by carefully selecting more default enclosures and sampling position scales, the aspect ratios and SSD achieves better performance. In comparison to the state of the art of object faster detection model RCNN, SSD demonstrates superior accuracy and the speed outperforming them on a various datasets. The real-time SSD 300 model operating at 59 frames per second suppresses other real-time alternatives like YOLO in detecting precision. The author suggests that SSD might be utilized as a building block in a more complex system with object detection component. They propose exploring its application in a system that use recurrent neural networks to simultaneously recognize and track objects in videos. Overall, SSD offers an efficient and effective solution for object detection, demonstrating its potential in various applications. Then the system analysis and feasibility. Existing system. This model focuses an already in use technique that was created utilizing a portion of Opencv PyTorch technique. Torch vision, one of the deep learning technique, it is used In this process, however, it was unable to achieve high accuracy and disadvantage, less support for the feature and inaccurate. And the proposed system is using OpenCV for a deep learning and a Renset 18 for torch vision approaches. We are executing the detection of either the helmet or not identification in the intended method. As a technique based on video analysis for helmet detection, the use of our suggested method will make it feasible to properly detect whether an individual is wearing helmet or not. And it is below is a block diagram. In block diagram, we take the video set and pre-process it and train the images that to detect whether the helmet is wear or not. And the advantages are low complexity, high performance, precise categorization, and simple identification. That is the architecture. In architecture, we can first data set and then take the system, then train the data sets, and the testing will be done. Then detection part will be done. That is whether they wear the helmet or not. And the methodologies and the algorithm. The computer vision is a cutting-edge technology that empowers machine to understand and analyze the images and videos. It allows us to manipulate visual data, extract valuable information, and make intelligent decisions based on what the machines see. This critical aspect of artificial intelligence finds applications in various industries and domains. Driving innovations in self-driving cars, robotics, and even photo editing applications. By leveraging the computer vision, machines can interpret the world, their environment, enabling them to function complex tasks, automate the process, and improve all overall efficiency. OpenCV is a powerful open source library known for its powerness in image processing, machine learning, and computer vision. It now functions as an integral part of a modern system, offering a real-time capability essential for various applications. By utilizing OpenCV, we can analyze images and videos to detect the faces, objects, even human handwriting. Python seamlessly interacts with the OpenCV's array structure when integrated with other libraries like NumPy, enhancing its analytical capability. Visual pattern and their distinct features are identified through a combined with the vector space technique that mathematical operations on these features. OpenCV's journey began with its initial release. Version 1.0, and it continues to evolve, making it a reliable choice for academic and commercial use. Thanks to its BSD license, the versatility of OpenCV extends across various platforms such as Windows, Linux, and Mac OS, iOS, and Android. It offers interfaces in multiple programming languages including C++, C, Python, and Java. It's a real-time capability where meticulously designed to enhance processing efficiency in practical applications. Image processing. Image processing is a technique used to manipulate and enhance the images by applying various operations to them. Its primary goal is to improve the image quality or extract relevant information from it. In simple terms, image processing involves analyzing and modifying digitized image to achieve a specific objectives. A digital image can be visualized as a two-dimensional function denoted as of f of x of y. Essentially, an image is represented as a two-dimensional matrix and or a three-dimensional matrix in case of a colored images, where each of element correspond to a pixel value defining the brightness and color of that pixel. Image processing is essentially a kind of signal processing, where the input is an image and the output can be either an alternate image or a set of characteristics that fulfill the specific requirement for that image. The methods employed in image processing aim to enhance, modify, or ability to draw out information from photos, making it a crucial tool across variety of a discipline, including computer vision, imaging in medicine, and remote sensing and photography. Tracking by detection. Tracking by detection is a preferred approach used in a multi-object tracking. As a detector improve in performance, the reliability of a tracking algorithm also increases. This method relies on object detection to identify object in each frame. Then it associates those detection across the consecutive frames to track objects over time. The challenges faced by the tracking algorithm evolved due to improve the object detection and often higher frame rates. PyTorch. PyTorch is a machine learning framework primarily developed by Facebook's AI research team. It is built on the top of a Torch library and is frequently employed for numerous tasks such as computer vision and natural language processing. PyTorch is an open source software distributed under the modified BSD license, making it freely accessible to the community. As its core, PyTorch is a powerful tensor library optimized for deep learning on both GPUs and CPUs. It allows the researchers and developers to efficiently work with tensors, which are fundamental data structures for neural networks. The framework's ability to leverage GPUs enables faster and more efficient training of a deep learning models, making it a popular choice among machine learning practitioners. Features listed in this document are categorized according to their release status. Stable. And the features marked as stable as well established and reliable functionality within the software. Maintenance, performance, documentation, backward compatibility, user assurance, long-term viability, recommended usage. And the second one is maintenance. Stable features will receive ongoing support and maintenance feature. Performance. User can expect these features to perform optimally without any significant performance restriction. Documentation stable. Features are truly documented with minimal or no gaps in provide the documentation. Backward compatibility, user assurance, long-term viability, and recommended user. Beta definition. Features categorized as beta are considered to be in a development phase with ongoing improvements planned based on the user feedback. Improvement scope. Beta features are labeled such as because there is a room for enhancement in terms of performance coverage among operators or API. And the user participation. User are encouraged to experiment with beta features and provide a feedback to help shape their development and make them more robust. Feature stability. As the beta features undergo iterative improvements, they have a potential to become stable and reliable functionalities in future releases. Prototype features are definition, accessibility, early testing, development focus, and limited availability and caution advised. Accessibility. These features may be accessible through runtime options or experimental builds. Early testing. Prototype features are still in early testing and feedback stage. Develop, Development focus. The team seeks user feedback to define and improve these features. Limited availability. Due to their experimental nature, prototype feature may not be as widely available or stable as other functionalities. Caution advised. User ought to be serious when using prototype features, as they may undergo changes and may not have a long-term support. PyTorch overview. Definition. PyTorch is a powerful tensor library designed for deep learning applications with GPUs and CPUs, and it was primarily developed by a Facebook AI research team. And PyTorch is an open source machine learning package for Python. Along TensorFlow and Keras, PyTorch is a popular and widely used machine learning library. GPUs and CPU compatibility. It is optimized to work seamlessly with GPUs, CPUs, making it suitable for high performance computing in deep learning tasks. Versatility. PyTorch's tensor operations enable researchers and developers to efficiently work with the neural network and handle the complex data structure. PyTorch tensor library and its support for GPUs, CPUs have contributed to its popularity as a go-to choice for deep learning application. Users should be aware of a prototype features, experimental nature, and consider the stability and long-term support when selecting features for their objectives projects. With its open source nature and activity community, PyTorch aims remains a valuable tool for machine learning practitioners alongside other popular libraries like TensorFlow and Keras. Feasibility study. Feasibility analysis is a crucial phase in the project development where the practicality and viability of the proposed system are evaluated. It involves presenting a business proposal with a generic project plan and a cost projections to ensure that the suggested solution aligns with the business objectives without causing undue strain. Understanding the main system requirements are crucial for successful feasibility analysis. The following three factors are indispensable to the feasibility analysis: economic feasibility, technical feasibility, and social feasibility. Economic feasibility. The economic feasibility research intended to assess the financial impact of the proposed system on the company. As a corporation has a finite budget for research and development, it is of utmost importance to ascertain that the costs are justifiable and supported by evidence. Under these circumstances, the developed system was successfully completed within the allocated budget, primarily on the account of availability of a free-to-use technology. Only specialized goods needed for purchased. Technical feasibility. The technical feasibility study focuses on evaluating the system's technical requirements to ensure that it can be implemented without placing a heavy burden upon the available technological resources. The extent of the technological resources available must be carefully considered to avoid straining the existing infrastructure. The client has a high expectations and the system's implementation should require a minimal or no adjustment to meet these expectations. Next one is social feasibility. The social feasibility study aims to evaluate how well the proposed system is accepted by its users. This involves understanding the level of user acceptances and ensuring that the system is user friendly and worth their money. The goal is to make a user view the system as a necessary rather than a burden. The technique used to familiarize the users with the system play a crucial role in determining the development of acceptance. Building user confidence is essential to encourage a constructive feedback and engagement. And the system requirement specification. Functional and non-functional requirement. Analysis of requirement is a pivotal element in determining if a system or a software project will be successful. Functional and non-functional requirements are two main categories of a requirement. And the functional requirement define the specific functionalities and features that the system or a software must perform to meet its intended purpose. These requirements outline the actions the system should execute and the expected behavior for the various inputs. They are directly related to the system's core functionality and are indispensable for reaching the desired outcomes. Examples of functional requirement for a safety element detection using industrial site using Opencv may include: the system should be detect safety helmets owned by the workers in the real time. It should accurately identify the location of a safety helmet in the images and a video stream. The system must trigger alert when it detects the workers not wearing a safety helmet. It should provide a real-time monitoring and analysis of surveillance footages. The system should be able to handle various industrial scenarios under diverse lighting circumstances and occlusions. Non-functional requirement specify the qualities, constraints, and the attributes that the system must possess beyond its core functionalities. These requirements address the system's performance, security, usability, and other factors that exert influence on its overall effectiveness and user experience. Examples of a Non-functional essentials for safety helmet detection system may include performance. The system should be capable of processing a video streams in a real time with a low latency. And then accuracy. The helmet detection models must achieve a minimum accuracy rate of 95%. Scalability. The system should be scalable to accommodate additional cameras and handle increased workload. Security. Access to the system and its data. Then the system specifications, hardware specification and software specification. Hardware, we use a i5 Intel processor and 8 GB of RAM and 128 GB of hard disk, and using 10 software specification of Windows 10 operating system with Python 3.6 server-side script, and use the IDE as a PyCharm and a VS Code. Libraries we are used are NumPy, iOS, PyTorch, Keras, Pandas, TensorFlow, Opencv. Then the system design. Input design in an information system is a crucial process that focuses on creating effective data input and entry procedures to ensure high quality system output. The designers consider various input methods such as PC, MI, CR, OMR, etc. to optimize data processing. The quality of the system's output is directly linked to the quality of its input. Well-designed screens and input forms process specific qualities including a task effectiveness, accuracy, simplicity, and user centricity. Objectives for input design: data input and entry procedures, input volume reduction, data capture techniques and some documents, user interface displays and data entry screens, efficient input controls and validation checks. And then first one is the data input and entry procedure. The primary objective of input design is to create efficient and user friendly data input and entry procedure. These procedures must facilitate the seamless and accurate input of a raw data into the system. Input volume reduction. Another goal is to lessen the input volume by employing a smart data capture technique or designing a source document that capture essential data effectively. Data capture techniques and source document. The designers aim to develop innovative data capture techniques and design source document that enable the efficient and accurate collection of data. User interfaces display the data entry screens. Input design focuses on creating a user interface displays and data entry screens that are intuitive and simple to navigate and meet the user needs. Efficient input control and validation check. Input design include implementing a robust input controls and validation checks to prevent errors and ensure the data accuracy and completeness. By accomplishing these objectives, input design enhances the overall functionality and the usability of an information system. The process ensures that the system efficiently processes input data, leading to accurate and reliable output. Output design is a critical task in every system, where developers determine the essential output type and consider output controls and report layout prototypes. The output design aims to create output formats that fulfill the required functions and prevent the production of adverse outcomes. It ensures that the output satisfies the need of the final user and is delivered in the right amount to the correct recipients. Timely delivery of output is crucial to enable informed decision making. And then the objectives of output design. The objectives are fulfilling the required functions and satisfying the user needs, producing adequate output, properly prepared and delivered, timely delivery. Fulfilling and requirement functions. The primary objective of this output design is to create output format that effectively fulfill the required functions of the system. The output should be provide relevant information to the users to support their task and decision making processes. Satisfy user needs. Output design focuses on meeting the needs and the expectations of the final user. It considers the preferences and requirements of a users to ascertain that the output is user-friendly and easily interpretable. Then producing adequate output. Output design aims to generate the right amount of output. It ensures that the information provided is sufficient and appropriate for users to perform their task efficiently, properly prepared and delivered. Output design ensures that the output is properly prepared, formatted, and sent to the correct recipients. It involves considering the layout, presentation, and distribution methods to optimize the usability of the output. Timely delivery. Delivering the results on time is a critical objective of the output design. Timely output enables the users to make informed and timely decisions, enhancing the overall efficiency of the system. By achieving these objectives, output design enhances the effectiveness of the information system by providing the users with the relevant and usable output. It ensures that the output meets user expectations and supports their decision making processes, contributing to the success and the worth of the system. And then the models we use the system and a user. The first one is system we done the dataset creation, pre-processing, and training and classification. In a dataset creation, the user initiate the practice of creating a dataset that include videos from the industrial side. And the pre-processing, the system converts the video into individual frames per second to prepare them for a further processing. Training, the user instructs the system to train the model using Opencv and PyTorch, utilizing pre-trained Renat 18 model. Classification, the system displays the result of the trained model, showcasing the detection of helmets and non-helmet instances in the video. Classification, the system displays the result of a trained model, showcasing the detection of the helmet and the non-helmet instances in the video. User, in the user user upload the image and view the result. The user interact in the conjunction with the system by uploading images to detect the appearances of helmet without helmets in them. View result, the system processes the uploaded images and present the user with the result. The user can precise the classified video result, showing instances of helmet and non-helmet, and also view the classified image result, indicating the detection of helmet without helmets in the image. UML diagram. Unified Modeling Language is UML is a widely used standard language in the realm of object-oriented software engineering. It is developed and overseen through the Object Management Group (OMG). UML's main goal is to establish itself as an officially recognized language for modeling object-oriented computer programs. The focus on expressing a complex system effectively. UML is composed of two main parts, a meta model and a graphical notation. The meta model provides a formalized understanding of the modeling language, while the graphical notation employs the visual representation to convey software project designs. The primary design objective of a UML are as follows. The expressive modeling language. UML aims to offer consumers an expressive and readily usable visual modeling language, enabling them to generate and interchange impactful model effectively. Then specialization and extensibility. UML provide a means for specialization and extensibility, allowing users to adapt the main principle to suit a specific modeling needs. Independence from development process and language. UML is designed to be independent of any specific development processes or programming language, making it versatile and widely applicable. Formalization of modeling language. UML formalizes the understanding of the modeling language, ensuring consistency and clarity in the model representation. Promote commercial expansion of object-oriented tools. UML support the growth growth and adaptation of object-oriented tools in the industry, facilitating the development and integration of advanced software solutions. Support for advanced development concept. UML encompasses the assistance with a more leading edge process concept involving alliances, models, design components, empowering developers to create a sophisticated software system. Embrace, embrace industry standards. UML aligns with the industry standards, ensuring compatibility and interoperability with the other software engineering practices. UML's versatility and standard approach have made it a key ingredient of the software development process, enabling developers to make, model, specifies, visualize, build, and document software artifacts effectively. It caters not only to software system but also finds applications in a business modeling and non-software system, making it a comprehensive and widely adopted modeling language. And the next one is use case diagram. A use case diagram in a UML is a behavioral representation that illustrates how the system works. It uses actors to show specific task use cases and the connections between them. The primary goal of the use case diagram is to demonstrate the task performed by each actor in the system. Actors are individual or entities with assigned roles. In a nutshell, use case diagram offers a clear visual view of how system functions and displaying actors, their task, and the other connections between them. It helps comprehend the roles and the interactions of various elements in the system. And the next one is class diagram. A class diagram in a UML is a static representation of a system structure. It shows classes, their attributes, and operations. The diagram illustrates how classes interact with each other. Each class in a diagram serves as a blueprint defining a common properties and behaviors for the system entities. It includes attributes acting like a variables that store a data for objectives of that class. In short, the class diagram provides a clear visual overview of the software system's structure, displaying classes, their attributes, operations, and relationships, which are essential for designing and understanding the system's functionality. Sequence diagram. A sequence diagram in a UML illustrates how elements in a system interact and their order of process. It visually shows how components or objects communicate and collaborate over time by exchanging messages during execution. It represents the sequence of a messages sent between objects and also called a message sequence chart. This diagram displays timing and events in the system's interactions. In short, a sequence diagram provides a clear view of how system elements communicate and work together over time. And then next one is collaboration diagram. Collaboration diagram is an interaction diagram in the unified modeling language, that is UML, that visually represent the communication and interaction between the objects in the system. It utilizes a numbering scheme to show the order in which the methods are called, with each number indicating the sequence of method calls. The collaboration diagram is particularly useful for illustrating the arrangement and relationship between the object during the execution of a process. It showcases the collaboration among objects and how they collaborate to achieve specific functionalities within the system. While similar to a sequence diagram in terms of a depicting method calls and interaction, the collaboration diagram goes beyond the sequence diagram by emphasizing the object arrangement and association among objects. It provides a comprehensive view of how objects work together and communicate to accomplish the task, enhancing the understanding of the system's overall architecture and the dynamics. And the next one is deployment diagram. Deployment diagram in UML display how system is placed on hardware devices. It shows the link between software component as the physical server, computer, and the router. The diagram visually demonstrates how these components are distributed across the hardware infrastructure. It helps the designers understand how software and hardware are connected and used together. By specifying where each part of the software runs on a physical hardware, the diagram aids in planning and managing the system's deployment for smooth operation. In essence, the deployment diagram offers a clear view of how software component interact with the hardware component. Then next one is activity diagram. Activity diagram in a UML usually represent a workflow that involve decision making, repetition, and concurrent activity. They show how system components work in operational and business workflows. Using activities and actions, these diagrams illustrate the flow of a control from one step to another. They help designers and stakeholders understand the sequence and a parallel execution of activities, including decision points and loops. And these diagrams provide a clear view of how tasks are connected and carried out, making it easier to plan, analyze, and communicate complex processes. In short, activity diagram offers a visual way to comprehend and communicate the flow of activity in a system or a business process. And the next one is component diagram. A component diagram visually shows how physical components in a system are interacted and organized, depicting their relationships and dependencies. It aims to illustrate implementation details and ensure all the system requirements are met through plan development. This diagram helps system designers understand how components interact, making it easier to build and maintain the system. In essence, it offers a clear view of how different components work together to meet a functional and non-functional requirements. And the next one is ER diagram. An entity relationship model uses an entity relationship diagram, ER diagram, to visually show how a database is structured. It acts as a blueprint for designing the database and creating it in the future. The main component of a ER model are entity set, representing related entities with their properties, and the other relationship set, showing connections between their different entity sets. The ER diagram displays the logical structure of the database, revealing the relationship between the tables and their attributes. It provides a visual representation of how entities are connected and interact within the database management system. In simple terms, an ER diagram helps to understand how data is organized in a database by showing how tables are related to each other and how they store the information. And the next one is DFD diagram. A DFD diagram is a data flow diagram. It is a method to use to show how information moves within a system. It provides a clear and a simple visual representation of a data flow. DFDs can be created manually or using automated tools and show how data enters, moves, and exists in the system where it is stored. The main purpose of DFD is to demonstrate the system scope and boundaries and help in effective communication between analysts and participants. It's a valuable tool for understanding the system requirement, identifying the data flow patterns, and facilitating the communication among stakeholders during system analysis and design. DFDs are essential for system improvement and redesign. And the implementation part, this code seems to be related to a web application that uses a detector library for the object detection on video and image files, particularly for detecting if people are wearing helmet or not. The proposed results are then made available to users to view through redirecting them to the prospective static files. And this code defines a function called detect that takes a pre-trained object detection model along with some additional parameters and performs object detection on each individual frame of a given video file. The detect function processes a video file frame by a frame using pre-trained object recognizer. It scales down the frames for faster processing, applies transformation to prepare the frames for the model and then predicts objects presence using this model. The captured objects are portrayed with the bounding boxes and labels, and the results frames are saved as a new video file. The purpose is to perform object detection and video visualize the results with the bounding boxes and labels. And this code snippet uses a detector library to perform a real-time object detection on a video stream. It loads a pre-trained object detection model, reads frames from the video, and predicts the entities found in every frame using the model. Objects with confidence scores above have a specified threshold are visualized with the bounding boxes drawn around them. The resulting frames with the bounding boxes are written to an output video file. The loop continues until the video ends or until the user presses the Q key. Finally, all the visualization windows are closed. This code is useful for detecting and visualizing objects in a video stream in real time. And this code snippet demonstrates how the detect library for the how to use the detect library for the object detection. It loads a free trained object detection model capable of detecting two classes, that is with helmet or without helmet. The model is then used to predict objects in an input image, and top predictions with the highest confidence scores are extracted. Next, the same model is employed to perform object detection on a video media 1.mp4. The detected objects are visualized with the bounding boxes, and the resulting video is saved as output.avi. Once the process is completed is printed as an indication. And in this code snippet, the detector library is used for object detection with the data argumentation. The code prepares the image argumentations using a torch vision transforms.compose function, creating a dataset with a specified argumentations. The set of a data loader to load the augmented data in batches. A new object detection model is then created with the classes with helmet and without helmet. The model is trained on the augmented dataset for a 5 epochs using fit function. Finally, the trained model is saved as hardhat.h5 for the figure object detection task. And the test cases. In the test case, the input is having input text and output is industrial video test for detecting helmet, and the result will be success. Test cases modeling building. And the test cases check out the dataset. Input dataset path, expected output dataset must be successfully read. The actual output is dataset successfully retrieved, pass or fail, pass. And then the processing the dataset in advance is a test case. Then pre-processing is carried out as an input, and the dataset should be undergo processing is as expected output. Pre-processing was finished successfully was actual output. And then building a model as a test case. Model building for a clean data is the input. Need to develop a model using the necessary algorithm is the expected output, and the actual successful creation of the model. And then the detecting is a test case, and the input image provide is input. Detecting a helmet in industrial videos should be the output. Then correctly classified a model is a actual output, and the result will be pass. Then the system testing. Finding errors in is a goal of a testing. The system testing include looking for any potential flaws or a weakness in a piece of a work. It offers a means of evaluating a functionality of parts, sub-assemblies, assemblies, and or a finished good. In order to make sure that the software system satisfies its requirement and user expectations and does not fall in unacceptable way, it must be put through a procedure called software testing. There are many different types of tests. A particular testing requirement is addressed by each test type, and the test types are unit testing, integration testing, functional testing, and system testing. Unit testing. In order to validate a program's underlying logic and guarantee that input results in intended outputs, unit testing is a component of a software testing. It entails creating a specialized test cases to look at a separate program component. These tests examine every potential branch of a decision making through investigate the internal flow of a code before being included into a larger system. Discrete software models undergo unit testing. It is an in-depth analysis of each unit's operation and is predicted on a comprehensive compression of the unit test design. Unit testing primary objective is to ensure that every component of a software operates as expected and perfectly complies with the set specifications. Unit testing promotes overall program dependability and quality by evaluating each component individually, enabling early problem detection and resolution. Next one is integration testing. Integrating previously independent software components or evaluating them as a whole in order to make sure they operate as a unified program without any glitches is known as integration testing, which is an important stage of a software testing. Integration testing emphasizes the confirming the links and interactions between the various components as opposed to the unit testing, which looks at individual pieces. And then a functional testing. The functional testing is a systematic and methodical approach to verify that the functions within a software system comply with the technical and business requirement. A system documentation, user manuals. The main aspect of a functional testing are valid input, invalid input, functions, systems, procedures. System test. And the system testing is a critical phase of a software testing that evaluates the entire integrated software system to ensure it meets a specific requirement. It aims to verify that the system behaves as expected and provides a predictable outcome under a various scenarios. During the system testing, the software is tested in a real world setup to simulate how it will function in a prediction area environment. The focus is on the overall system configuration and how the components work together to deliver the desired functionality. There are white box testing, black box testing, and integration testing and acceptance testing. White box testing involves testing software where the tester has a knowledge of its internal structure, code, and a purpose. The black box testing involves testing software without any knowledge of its internal structure, code, or implementation details. Integration testing. Software integration testing is a process of testing a two or more integrated software component together on a single platform. And the acceptance testing. Any project's testing phase is critical and necessitates the environment of end users. It makes that the system complies with the stated functional specifications and is well liked by the users. In order to guarantee that the system functions as intended and meet a user's needs and expectations, users play a critical part in testing it. Then the conclusion. The safety helmet detection system developed using Opencv has proven to be effective in determining whether the employees are wearing a safety helmet in an industrial setting. By integrating this system into the site's existing system measures, it has the potential to significantly enhance the safety standards and prevent potential accidents or injuries. However, to ensure the system's reliability under different lighting conditions, orientations, and challenging environments, further adjustments and testing may be required. Additionally, to make the system more suitable for real world industrial applications, it could be beneficial to integrate it with the real time video stream and optimize its performance by using the appropriate hardware. And the next one is the future scope. The potential for a safety helmet detection project using Opencv in industrial site is highly promising. There are numerous emphasizing chances for further enhancement and expansions. And the first one is real-time deployment. Currently, the project is focused on processing still images or record video. However, future work could be optimize the procedure for real-time processing of a live video transmission for surveillance camera, enabling instant helmet identification in live scenario at industrial site. And then multi-class detection, advanced object detection model, integration with IoT and the edge computing, cloud integration and the data analytics, and anomaly detection, robustness to different conditions, integration with access control system, multi-camera setup, and human feature analysis. Implementing these future improvements may require a diverse and extensive training dataset along with exploring and transfer learning techniques with a large scale object detection model. Continual monitoring and evaluation will be crucial to ensuring the system's ongoing performance and adaptability to evolving industrial context. These enhancements will contribute to achieving even higher safety standards and preventing the potential accident in the industrial environment. Thank you.